Okay, so for today we are doing EMATH coordinate geometry. So for EMATH coordinate geometry, there are three parts. So you go through them one by one. So for the first part itself, right, the first one what we have will be to find the length of a line segment, okay, or given two coordinates, okay, coordinates, okay. So let's take a look how we're going to do about it. So now let me draw out the coordinate geometry, the coordinate itself. So assuming is okay, x and y, right? So if let's say I have 2 point A, let's say this is coordinate 2, 3, and I have a point B, that is the, let's say I have 5, 7. So let me draw out this one. Okay, so let me draw nicer a bit. Okay. Okay, so assuming this is a line, so for a distance, okay, let's draw a right angle triangle. So by Pythagoras theorem, we should know that. Let me label it as C. Right? In set 2 we learned about Pythagoras theorems, so we know that AB squared is equal to AC squared plus BC squared. Okay, so how can I find this? So AB, right? I don't find AB. AB is the length that I want to find. So let's take a look. Basically AC. So let's take a look on AC itself. AC, right? We know that this is 2 and this is 5. So length AC will be 5 minus 2, right? 5 minus 2, right? So what I can say here is this is equal to 5 minus 2 squared, right? So how about BC? BC is on the y-axis, right? So I know that this is 3 because this is 3, this is 7. So I know that BC is 7 minus 3, right? BC is 7 minus 3, so I know that this is 7 minus 3 squared. Okay, so with this, right, I will know that AB squared is equal to square root. Let's don't have a square, so now you find AB, right? There will be a 5 minus 2 squared plus 7 minus 3 squared. So if I press my calculator itself, so I will get 3 squared plus 4 squared, and this will be 25, and AB is 5. Okay, so this is how we find the length, or how you find the length. So now let's generalize this. Let me copy this one. Right below. Right, so with this, right, let's generalize this one. So now instead of giving you the coordinates, now if I said that I don't know what is this, I also don't know what is this. So which means that this will be a, let's say this is x1, y1, and this is x2, y2, right? x2, y2. So just now we talk about this is 7 minus 3 for BC, 7 minus 3. So 7 basically is our x2, no sorry, our y2. So it's y2 minus y1, and similarly here is, okay, is our x2 minus x1. So with that, let's put back in our formula. So I know that AB squared, okay, is equal to y2 minus y1 because of BC. Okay, AB squared equal to BC. No, let's use AC first. Okay, let's use BC squared plus AC squared. Right, so AC is y2 minus y1 squared, and AC is x2 minus x1 squared. Okay, so AB will be square root y2 minus y1 squared plus x2 minus x1 squared. Okay, so this is how the formula it is. Okay, so with that in mind, if I said giving you 2 points, giving you two coordinates, or giving you two coordinates, let's see how we apply this. Giving you two coordinates, let's say I have two coordinates, let's say C, right, is -2 -5, right, and D, okay, let's say it's -7 -10, right. So I know that CD is equal to square root y2 minus y1 squared plus x2 minus x1 squared. Okay, so at the start, what we can do is we can label this. I can label this x1 y1. This is x2 y2, right? And I just need to replace it. So is -10 minus -5 squared plus -7 minus, yeah, I should use a square bracket, -7 minus -2 squared. So what I will have is I will get, you press the calculator, I'll get 50, and I write it down this way. So I will put it to 3SF units, right? 3SF. Okay, so this is how we use the formula for distance between 2 points. Give you two coordinates, you are able to find the the distance. Okay, can. Okay, so now let's go to the second part. We're talking about gradient, to find gradient, right? Gradient, we use m to represent gradients. So let me put back my things here. So similarly, for the same diagram, so we know that gradient m, gradient m is rise over run. So rise is where? Rise is here, right? This one. Let me use another color. It's rise over run, right? It's rise, right, over run, right? Okay, rise over run. Okay, it's rise over run. So rise is basically, for this is 7 minus 3 over 5 minus 2, right? So that's my gradient. So if that, similarly, if we generalize it, so I can say that this is x2 y2, and this is x1 y1. So similarly here, I will have a y2 minus y1, and here will be a x2 minus x1. Okay, or x1, right? So my gradient will be y2 minus y1 over x2 minus x1. Okay, so giving you two coordinates, you are able to find the gradient, right? Giving you two coordinates, you are able to find the gradient of the line segment using the formulas. Okay, so the last one we are trying to find, let me use another page. We'll try to find equation of a straight line, right? Equation of a straight line, or rather a linear functions. So equation of straight line, the gradient intercept form will be y equal to ms plus c. So m is our gradient, right? Okay, and then c is the y-axis intercept. Okay, okay. So that is, so if you draw it out, okay, this will be my c, and I can use the gradient formula that we have to find the gradient. Okay, so for equation of straight line, there are three conditions that you can find equation of straight line. The first one is if the questions is given the gradient, let's say gradient is 2, the gradient is 2, the y-axis intercept is 5, right? Okay, y-axis intercept is 5. So I know that gradient is 2, c is 5. So I know that y equation of straight line is y equal to ms plus c. So I just need to put in gradient and the c. I will get equation of straight line. Unlikely this is the case in exam, but you know, right? We need gradient, we need intercept. Okay, so that's first condition. Second condition, second thing that they will tell you with for a straight line, they will just say that, okay, they'll give you gradient. That's it, given. If the question tell you that you're given a point, right? You're given a point, with a gradient. Let's say gradient is 2, right? It passes, right? It passes, let's say a point 37, right? 0.37. Let's take a look. The gradient intercept form of a straight line graph is y equal to ms plus c. So I put in the gradient, which is 2, right? So we know that c is a constant, x and y is variables. It depends on the point that we have. So we know that it passes through 3 and 7, or 0.37. So which means that when x is 3, my y must be 7. So 7 equal to 2, 3 plus c. 7 equal to 6 plus c. C is equal to 7 minus 1, which is 1. Okay. So after finding my c, I can put it down, 2x plus 1. Okay. So this is the second condition, which is gradient is given and it passes through a point. Okay. So that is the second condition, second things. Okay. The third scenario will be, right, the question never give you the gradient. What they give you is said that it passes 2 points, right? Passes 2 points. The 2 points are, let's say, 2, 5 and 4, 9, right? 2, 5 and 4, 9. So we know that equation of straight line is y equal to ms plus c. We need gradient, we need c. So what we have learned before this is, give you 2 points, I'm able to find gradient. That's the formula for gradient, right? So this is x1, y1, x2, y2. Okay, so you might ask, can I label this x1, y1, this x2, y2? Why not? Okay, you can, but it must be consistent. But for this case, I will label in this way. Okay, so now let's take a look. Step replace the number. So is 9 minus 5 over 4 minus 2, right? So that will be a 4 over 2. Gradient is 2, so I know that y equal to 2x plus c. So I need to find the c. To find c, what should I do? I can use either, okay, I can use either 2, 5 or 4, 9, okay, whichever you think is more convenient. So let me use 2, 5. So when x is equal to 2, y is equal to 5. So I replace it in 2 times 2. No, let's not do that. Okay, 2 plus c. So 5 equal to 4 plus c. C equal to 5 minus 4 equal to 1. So equal to y equal to 2x plus 1. Okay, so this is how we can find equation of straight line. So the question will either, in order to find equation of straight line, you need to have either gradient and y-axis intercept. If the question give you, that means you need to have these two. You can straight away put it in. If not, right? If not, you need to have, if you have gradient by itself, you need to have another point. Any point that passes through, you can find equation of the straight line. The third one will be if the question give you 2 points. So long as I know 2 coordinates, 2 of the coordinates that the line will pass through, I can also find equation of straight line by using this method. Okay, I hope this is clear.